All right, here are quiz 4 solutions for Math 243. There's two different questions or parts to this quiz, I suppose. First one dealing with sampling distributions. Second one dealing with a confidence interval, I believe. So let's go through it. Lots of questions. Suppose that the amount of time spent on a mountain during an attempted summit of Mount Everest is normally distributed with a mean of 50 days. So this is my population mean here. This is mu. This is 50. And a standard deviation of 12 days. So this is sigma. My population standard deviation. Those are the center and spread of the parent distribution. You plan to randomly select 16 people in order to create a sample so we can get sample averages so we can ask sampling distribution questions. That 16 is my sample size, it's n. And track how long each one spends on the mountain. Determine mu, sigma, and n. Those are the things given to you in the problem. Mu is 50, sigma is 12, and n is 16. A little redundant to write it up here and down here. What are you going to do? What about the shape of the sampling distribution? The shape is approximately normal. It's always going to be normal or approximately normal. Either way is fine. Hence the parentheses in this class. Because otherwise you couldn't do the problem. There's two different reasons it could be approximately normal. Either because n is greater than or equal to 30. In this case it's not. Or because it tells me the parent distribution shape is approximately normal. So because parent distribution is normal. And just for the sake of your notes, it says that somewhere. Oh, this was a bad way to get there. Boom, got it. Normally distributed. What is the center of the sampling distribution? State your answer using the correct symbol for this value. It's mu with a little x bar in the subscript is the correct symbol for this value. The nice thing about mu sub x bar is it's always just equal to mu. And mu is equal to 50 in this problem. It's given up here. What is the spread of the sampling distribution? That's sigma sub x bar. That one's not just equal to sigma. It's sigma divided by the square root of n. So sigma in this problem was 12. And n in this problem is 16. And you can leave your answer like this. Or you could say this is 4 and 12 divided by 4 is 3. Whoop, that's not a 3. 12 divided by 4 is 3, I promise. Round to 4 decimal places, that's probably unnecessary. I'm going to erase that before I post this quiz. Present your answer to the 3 questions below with the sketch of the distribution in question. What is the probability that your sample average is between 49 and 55 days? Sure. Well, I'm going to draw the sampling distribution because the question is about my sample average. And the center of that sampling distribution is 50. And I want between 49 and 55. Can arbitrarily put one to the left and one to the right. Doesn't have to be drawn to scale. If you want to draw it to scale, you feel free. This is the area I'm looking for because the probability that the sample average falls in this range is one of the interpretations of the area underneath the sampling distribution. So to figure this out, I'm going to use the normal Cdf calculator function because I want to find the area. Lower bound is 49, upper bound is 55, center is 50. Spread is 12 divided by the square root of 16, or 3. Whichever one you prefer is fine by me. And what you're going to do is find the normal Cdf function under the distribution menu, so second and then variables. It's the second thing listed. Lower bound is 49. Upper bound is 55. Center, even though it says mu, it really wants the center. Spread, even though it says sigma, it really wants the spread. Paste that all in. And it tells you this area. It says it is 0.5827. Did I say how to round this? I better add that. Let's say I asked you to state it as a percentage and then round that percentage to 2 decimal places. It would be 58.28, I suppose. That would be the answer to this question. Second one, what is the probability that a randomly selected individual? Okay, note that it's a randomly selected individual. So question is about parent distribution. Right, not the sampling distribution. I kept these numbers the exact same because I wanted you to really see the one thing that I changed. If I changed this and this, you might miss that I changed this. The idea is since we're talking about one single individual, we're talking about the parent distribution here. So while the picture might look the same, maybe I'll change the instructions so you don't have to redraw the picture this many times. This area is going to end up being different. because my spread is different. I'm still going to use normal CDF. My lower bound is still 49. My upper bound is 55. My center is 50. Not because mu sub x bar is 50, but because mu is 50, because this is parent distribution stuff. And then my spread is 12. 12, I thought it was 3. Nah, it's 12 because the question is about the parent distribution. Type that all into your calculator. Let's see, I'll cheat. I'll hit second and then enter to pull up the most recent entry. And then I'll just change this 3 into a 12. Save time. And get 19.47%. These obviously aren't drawn to scale because they look about the same, but this one is quite a bit bigger than this one. But don't worry about drawing to scale. It's not an art class. Get the answers, we're good. How high would your sample average have to be in order for there to only be a 5% chance that another sample average of 16 people exceeds it? Okay, again, we're talking about sample averages here. So now we're back to the sampling distribution, not the parent distribution. So this question is a lot more like part 1 here. Sample average. This tells me it's sampling distribution as opposed to this one that was parent distribution. I want some average really high, so way off to the right. How far off to the right? Well, so far off to the right, that's a weird looking one. But the area right of it is only 5%. Because if the area right of it is only 5%, there's only a 5% chance that another sample average exceeds it. My center is 50 because mu sub x bar is 50, and I need to find this number. Maybe I'll call it x. The way I get that is by using the inverse norm function on my calculator. Inverse norm always wants the area below the point, so 0.95. The center is 50, and the spread, careful here, it's not 12, it's 3. So spread was 3, spread was 12, spread was 3. Hit second and then variables to get into the distribution menu. Inverse norm, 0.95, 50, and 3. Try that 50 again. Then I'll hit enter and it spits out, hit enter a couple times apparently. 54.93. I better tell you how to round this. Maybe I'll tell you to round it to, I don't know, 2 decimal places. Sure. All right, question 2. Question 2 is different than question 1 because in question 2 we're going to be talking about a confidence interval. You'll see that there's a lot of connections between the two as we saw in our written problem this week. But it'll be set up a little bit different because I'm trying to be really consistent with how these things are set up. So confidence intervals will always look like this. You always have the same information given to you. You'll be told your sample size, in this case it's 50. You'll be told the sample average, which is x bar, in this case it's 30. And you'll somehow know the population standard deviation, sigma, is 20. And the fact that we have a 95% confidence interval, that ends up telling us that alpha, well, I'll get to that later, that alpha is 5%, but we don't have to worry about that right now. State and justify the shape, center, and spread. Sure. Shape is approximately normal. How do you know it's approximately normal? It doesn't say anything in here about the shape being approximately normal. It doesn't tell you about the parent distribution. But it does tell you that the sample size is large, and when the sample size is large, the sampling distribution shape is approximately normal, regardless of the shape of the parent distribution. So approximately normal because n, which is 50, is greater than or equal to 30. What about the center? The center of your confidence interval is always given by x bar. It's called a point estimate. It's equal to 30. And the spread, you might be thinking is sigma, but it's not. It's sigma divided by the square root of n. We're talking about sample averages. The picture for confidence intervals looks like the sampling distribution picture. So it's 20 divided by the square root of 50, whatever that ends up being. I think those are the exact same numbers, or at least similar to what they were in the written problem. At any rate, sketch a picture of the distribution showing your level of confidence, the point estimate, and the bounds of your interval. Sure. There's my picture, approximately normal. There's my center. My level of confidence was 95%. Says that up here. So I'm going to shade in the middle 95%. You can write the 95% in the middle or label it from the outside. It doesn't matter. And then you need to find these bounds right here. And yeah, you could get there with inverse norm, but don't get in the habit of, get in the habit of going over to tests and then selecting Z interval and giving it all the information that's given to you. Sigma's 20, X bar is 30, so I guess it's not the exact same numbers as your written problem. N is 50. That all right? Yeah, and the confidence level is 95%. Calculator will spit out a couple numbers, 24.456 and 35.544. Last thing. How about that? I thought there was a part 4 on this, but I guess not. Last thing, state your conclusion in a sentence or two. Okay, sure. What this tells me is I don't know the population average, but I'm pretty sure that it's somewhere in between these two values. Right? Mu was not given in these problems, X bar was. But based on that sample average, I can say the population average is in between these two numbers. Yeah, you're sure? No, I'm 95% sure, though. I am 95% sure, or certain, or confident, or whatever, that and I like to write population, although you probably wouldn't lose credit if you didn't. The population average, or the average, what are we talking about here? Age of mountain climbers on Mount Everest, not this sample, but all of them. The population average age of Everest mountain climbers. My dog's about to start barking. Maybe I could finish this video before she starts. Is between these two values, 24.456 and 35.544. Cool. That's the end of this quiz.